Alright, in this lesson we looked going right back at the basics of the data analysis tools that you would have learnt over your time in school and the basic definitions of those things. So, to take you through the bullet points that we discussed, when we're working with data that we've gathered but it hasn't been ordered or grouped in any way, so whether we're taking it off a questionnaire or a survey, or we're marking things down on a clipboard, if nothing has been done to that data yet, then it's known as raw data. Any data that we're measuring using a stopwatch or a tape measure or weighing scales, anything like that, is said to be continuous data because we're deciding how accurately we are going to measure that. So if I'm timing people running 100 meters, then I would be using a stopwatch and probably measuring seconds to one decimal place, so 14.3 seconds. If I was measuring people running a mile, then I probably wouldn't need to measure so accurately, and it would be measured in minutes and seconds. So depending on how accurately you need to measure something, that data is said to be continuous. If you are counting the data, so if you were doing a survey where you're counting different eye colours or car makes or anything like that, then that data is said to be discrete. When we analyse, we try to find something to describe a typical value for the data. It's the sort of value that you would expect to find because there's more of them than anything else, for example. That's known as an average. But we also can measure how spread out the data is, and that's called the range. So a common mistake when talking to students about averages, if I ask them, well, can you give me an example of an average? They would talk about mean, mode and median, but they'd also say the range. The range we use as a measure, however, it isn't an average. It gives us a measure of spread, how spread out the data is. I will see that in some of the examples we look at shortly. So there are three types of average that you need to be able to find for a set of raw data. Now you can't find all of them for all types of data, but these are what they are. So we have the mode, and I've written there mode with a capital M and a capital O because it occurs most often, most frequently. So mode, most. Mean, I like to think that the mean is mean because it's the one that's the most work. It's where you have to total up all the data values by adding them together and then dividing by the count. How many data values have you got? So that's a lot of work. It's really mean. And then the other measure is median. This is the middle value of the data. Once the raw data has been sorted, that's really important. It has to be sorted in order of size before you locate the median value. So for median, think medium. If the list has got an even number of data items in, then it hasn't got a middle. Then what you do then is you find the middle of the middle pair. So you find out what's halfway between the two middle values. As far as range is concerned, at the intermediate tier there are two different measures that we will learn about. The first one is the range, which is the one you will be most familiar with from Key Stage 3, and that's the biggest data value, the largest data value, take away the smallest data value. And then when we come to look at cumulative frequency in later lessons, the interquartile range is another form of range, another form of spread that you get from cumulative frequency. But in both cases, the larger that value, the larger the range, it means the more spread out your data is. For continuous data, we can look to find a value for each measure of average and calculate the range. But for discrete data, we can only find the mode. If you're doing a survey on eye colours, for example, you can't add them all up and divide by however many there are because they're not numerical. And similarly, you can't order them in order of size. So for discrete data, the only average you can measure is mode, what's occurring most frequently. And the GCSE, you may be asked to decide which measure of average best describes a set of data. Okay, let's take a look at a couple of examples. So consider the following marks scored by 13 students in a maths exam. We want to find mean, mode and median and the range of these. Now you can see that the data is already in order. So to find the median, first of all, I'm going to be looking for the middle value. So I think it's there, so we'll check both sides to see if there's the same number of data items each side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the median in this case is 25 because that is the middle value. Then for the mode, we're looking for the most frequent. And the most frequent is 27 because it occurs 3 times. And then for the mean, first of all we need the total. So we have to add all of those up. So 20 plus 21 plus 21 plus 22, 23, 23, 25, 27, 27, 27, 29, 98, it's 461. The count, however many there are, well, it tells me there are 13 there. So the mean is the total divided by the count. So 35 to 1 decimal place. Next digit is a 4, but beyond it is 5 or more, so that rounds up to 35.5. And then the range is the largest value, which is 98. Take away the smallest value, which is 20. So that's got a range of 78. Now, I've got a mode, which is 27. I've got a median of 25. And I've got a mean of 35.5. Now, in the context of this data, right, what this data is all about are marks scored in a maths exam. Now, if I was that maths teacher and I wanted to brag about how well my class was doing, of those 3 averages, the 27, the 25 and the 35.5, which of those would I be most likely to walk into the staff room and say, hey, my kids are doing well, their average is? Well, hopefully you'll be seeing that if I want to brag, I'd be saying that because it's the highest of the 3 measures. So I'd be saying, oh yeah, my class are doing really, really well. They had a mean of 35.5. On average, their average score was 35.5. But if you look at the data, with the exception of these 2 that almost got full marks, the rest of them are much lower than that. So that's not really a fair average to represent this data because it's being affected by those high marks. And it's been affected by those high marks because I've had to add them all together. So a couple of really, really high marks is going to make that total large. So that's why when I mentioned on the previous page, you may be asked to justify which measure of average is the best to use. Now with this one, the mode of 27 or the median of 25 is a much better representative of that data, because if those two, who may well have been in the wrong class, weren't in the data, then that the median would change slightly, the mode wouldn't change at all, but the range would be much smaller. Look, it would be 29 take away 20 is 9. So it goes back to what I was saying on the first page. The bigger that number is, the more spread out the data is. It's telling you. It's a heck of a difference between a range of 78 and a range of 9. So taking a look at the second example, the following are the salaries of 5 employees in a small business. So Mr. A is earning 22,500, Mr. B 17,900, Mr. C 21,400, another person, Mr. D, earning 22,500, and Mr. E earning 155,300. Find the mean and the median salary for the business, which does not give a fair average. Explain why. So for the median, I need to put them in order first of all. So in order, I'm going to have 17,900, then 21,400, and I put a little dot underneath once I know that I've copied it over so I don't miss anything out. Then Mr. A, 22,500, Mr. D, 22,500, and Mr. E, 155,300. So the median is the middle. If I put my pen there, I can see I got the same number either side. So the median salary is £22,500, as is the mode, because there are 2 of them, but this question is not asking for the mode. Then to work out the mean, I need the total. So 17,900 plus 21,400 plus 22,500 and another 22,500 and 155,300. So the total salary is 239,600. The count 1, 2, 3, 4, 5. The mean 239,600 divided by 5. 47,920 pounds. So in the context of what we're talking about here, this data is all about how much money people earn who work for this small business. We've got a median of 22,500 and we've got a mean of 47,920. So when you now look at the data that we were given, which one of those is not a fair average to use? Well, hopefully you'll be saying that that one is high. If, just like with the question above with the marks, if you take out those top ends, those 2 clever kids, the rest of the data is much lower. In the same case with this, if you take out that one person, Mr. E, who's earning 155,300, all the rest of the salaries are in the 20s or high teens. So this is much more representative of the data than that. Now Mr. E probably owns the company, so he's entirely entitled to that salary, but if that's being included in the mean calculation, then adding that amount in makes that very high and inflates the mean. So which does not give a fair average. The mean doesn't give a fair average, as it has been inflated by the very high salary of one employee. And that's all you need to say. You're being very clear that that is much higher than the rest of the salaries put together. So when you are working with mean, mode, median, range, be prepared to look at the values that you're calculating and make a decision as to whether or not they're all appropriate to describe the data. Sometimes they are. Sometimes the data will be absolutely fine, take your pick. But if your data has an unusual high or an unusual low value that doesn't fit in with the rest of the data, then the mean is likely to be affected.